This video is designed to give you an idea how to find surface area of pyramids and cones. We'll focus on regular pyramids and cones. As you can see, I've written regular pyramid, and that means that the tip is centered over a regular polygon base, in this case a square, to make it nice and easy. So in order to do this, what we need to do is keep in mind that our plan is to find the total surface area by adding together the area of all the faces. That means there's 4 triangles that are all the same. So it's 4 times the area of one of the triangles plus the area of the base. Now the area of the base is easy in this case. It's a square and it's 10 by 10. So we can just fill that in. What's a little trickier here is that these triangles are not 8 high because they're tilted in to lean into each other to make the tip of the pyramid, which means if you stood them up, they'd be taller. Well, how tall are they? Well, we'll figure that out in just a moment, but let's be careful to write the formula for the area of a triangle, which is 1/2 base times height, and fill that in, and then remind ourselves our challenge is simply to find the base, which is 10, and the height, which we're going to call the slant height. So what we have is 4 times 1/2 times 10 times some mystery height we're going to call S, plus 100 for the area of the base. Now, what we actually have, if we make this nice triangle inside here, this right triangle can be drawn off to the side. I'll draw it in blue off to the side. And if we're careful and put the dimensions on it, this is going to give us the line that is the slant height right here. This is going to be the slant height. That is the height of the slanted or tilted triangles. So, in order to find these, let's draw that triangle off to the side. Now, since we've brought the tip straight down to the middle of the base, the dimensions down below on the bottom of the triangle is going to be 5. That's half of our 10 all the way across the base. And of course, the height of this right triangle is the same as the height of the pyramid itself. So what we're looking for is to find S, and S, of course, then can be found using the Pythagorean theorem. So we've got 8 squared plus 5 squared equals S squared. And if you sort that out, you're going to find that S is the square root of 89, which is approximately 9.43 centimeters or so. Now what we have is something that we can fill in easily. And so we're going to get that the surface area is approximately 4 times 1/2 times 10. And of course I could be simplifying that right away, but I'm just going to leave the numbers for now. Plus 100, okay, and then pretty straightforwardly, 4 times 1/2 times 10 is 20 times 9.43, which we'll check out, times 20 is 188.6 something, so 188.68 roughly, plus 100, so our total surface area is going to be 288.68 centimeters approximately, centimeters squared, excuse me. Okay, so keep in mind that this requires you to find the slant height. These triangles are not 8 centimeters tall. They are 9.43 ... centimeters tall, because what you're finding is the slant height, and this is something that you can also do for the cone, which we'll see on the next slide. So this second picture is a drawing of a cone, and we're going to say that it is 10 centimeters tall and has a radius of 6 centimeters. Now once again, to find the surface area, we need to kind of keep our plan in mind. The surface area total is the area of the base, which is a circle, plus the area of the sides of the cone. Now that's a bit more of a challenge. So let's take a look at how this lays out. If you were to make a piece of paper to fit over this cone, you would wind up getting a fan shape. And that fan shape, if you cut it up into a bunch of slices, much like figuring out where the formula for the area of a circle comes from, if you cut it up into a bunch of slices and you took all those slices and you put them together, one up, one down, one up, one down, like that, you would get a shape that, as you kept going, would have a parallelogram shape. Essentially, it would be a rectangle once you cut those slices very, very, very thin. So the height of this parallelogram is, once again, this mysterious slant height, which is going to be the height that we calculate, once again, by using a right triangle inside the cone. Okay, so it's the hypotenuse of that right triangle. It's how long it is from the tip of the cone down to the outside of the base of the circle. And so that slant height has to be calculated once again. Now, the other question is, how long is this parallelogram that we construct? Well, the total length all the way along here is equal to the circumference of the circle. And so, since we use half of the pieces of wedge-shaped pieces to make the top of the parallelogram and half to make the bottom of the parallelogram, what we have is half the circumference of the circle. What is the circumference of that circle? The circumference of that circle, so it's going to be half the circumference, or pi times the radius. And that's the radius of the base circle. So if we are careful and plug in this information, we're going to get that the area of the base, of course, is pi r squared, and the area of the sides then is the area of this parallelogram. Now, how do you find the area of the parallelogram? You multiply base, which is pi r, times the height, which is s in this case, the slant height. So that means we're going to find the the area of the sides by doing pi r s. So we need to calculate what s is using the Pythagorean theorem. Let me draw that triangle once again off to the side. I'll remind you that it looks like that. And it's got a height, in this case, of 10 centimeters and a base of 6 centimeters, and it's a nice right triangle. So we would use the Pythagorean theorem to calculate this. And so that's going to be the square root of 10 squared plus 6 squared, or the square root of 136, which is going to, of course, be, let me put that in, 136 square root is going to be approximately 11.66. So S in this case is approximately 11.66. You can check that for yourself by doing the Pythagorean theorem. And what we're going to get is then pi times 6 squared plus pi times 6 times 11.66. Now remember, it's not the radius of the circle and it's not the height of the cone, but in fact it's the slant height of the cone, which is in this case 11.66. If we are to calculate this out a little bit now, we'll get 36 pi, and 6 times this number is going to be 69.97 pi approximately. And you could combine those two and get an answer in terms of pi, which we've talked about some of the time, 105.97 pi. But you can also simply multiply that by whatever version of pi you're using and get an answer of approximately 332.9 or so centimeters squared. I hope this has clarified what's going on. Once again, identify the faces that you're finding the areas of. Try to use the appropriate formulas for finding those areas. Find those areas, add them together. Keep that plan in mind, and then identify the dimensions as you go along, meaning finding the slant height or the radius of the cone, etc.